many years I was technical director at a UK PCB fabricator, and I'm currently a technical consultant and technical editor. I'm a member of the Council of the Institute of Circuit Technology, which is dedicated to technical aspects of printed circuit board manufacture and assembly. Originally established in 1974 as a forum for discussion on technology matters related to printed circuit interconnection, the Institute continues to successfully provide its members with opportunities to improve their knowledge of manufacturing process technologies, materials and practices, and to stay in touch with current and future developments. The future of printed circuit manufacturing and assembly will rely heavily on automation and the establishment of the smart factory. What will this involve, and what additional skills will engineers need to learn? A leading expert in this area is Happy Holden, Honorary Fellow of the ICT, who's kindly offered to deliver a series of one-hour webinars based on his recently published ebook, 24 Essential Skills for Engineers, which is free to download from the iConnect 007 website, and which will form a valuable resource for in-house training of engineers and their career development. Happy has been directly involved in advanced PCB technologies for over 50 years, with a career that has seen him as Director of PCB R&D and Engineering Manager of PCB Manufacturing at Hewlett Packard, Advanced Technology Manager at Nanyar, Westwood Associates and Merrick's, Senior PCB Technologist at Mental Graphics, Chief Technical Officer for Honhai Precision, the world's largest PCB fabricator, and latterly Director of Electronics and Innovations for Gentex Corporation. He is co-author of the Printed Circuits Handbook and has been a prolific technical writer and educator. In his retirement, Happy continues as a contributing technical editor with iConnect 007 and is always keen to share his vast knowledge and experience. In this first presentation of this series of webinars entitled Automation and the Journey to Your Smart Factory, Happy introduces the elements of the journey and discusses the key issues: who, what, how long, when, and how much. His emphasis is very much on avoiding factory automation consultants who will generally charge you for learning your processes and procedures while selling their own equipment or software. Instead, Happy suggests you select your own engineers that are familiar with your own processes and procedures and let them learn how to do the automation planning. Then they can teach others this essential skill, which the factory will need over and over again. If you have any specific questions, please direct them to happy@iconnect007.com. So it gives me great pleasure to hand over to Happy Holden. Thank you.
Greetings, everyone, and welcome to an exciting webinar prepared by iConnect. There we go. Hopefully everybody can hear me now. You know, as enthusiastic as we all are, and I thank Pete for the gracious introduction. Pete is our senior kind of spokesperson involved in all of this. This webinar is put together, frankly, because I'm winding down my career after 50 some years, and I want to uh, apologize right now for the uh, maybe the subtleties or difficulty in presentation might have over the next couple ones. I'm recovering from a knee replacement surgery, and with some of the narcotic painkillers and things like that, I have a kind of brain fog, which hurts my presentation. I would normally love to do this in person, where I could look at each one of you. And talking to my screen is not quite the same in terms of my memory. That, and I'm getting up in age, which doesn't help the memory. So it's best that you see this now and record it, and it is being recorded. So you can go back later and download it from ICT if you want to refresh or conduct classes in your own operation or for customers. I'm a member of the ICT for many years and follow their excellent work. With that, I want to combine my last 50 years. I've been involved in factory automation in printed circuits since the very day I was recruited by Hewlett Packard out of the university to join their integrated circuit thin film fabrication. I spent 6 months working on thin film microwave substrate manufacturing until Hewlett Packard asked me if I would go down the hill and help out their struggling printed circuit fabrication operation, since I was the only chemical engineer Hewlett Packard had at the time in 1970. My first question was, remind me again, what's the printed circuit kind of thing? So that was my introduction to printed circuit fabrication. But working with the printed circuit people and focusing on the various problems and solutions for that, I became totally engrossed in the technology. In the semiconductor or thin film area, I only have a master's degree, and without a PhD, I'm still a technician. But in the printed circuit fabrication, I found there's lots of opportunity for that. And so since you'll see in some of the other lectures, some of the diagrams are pictures of my work in automation at Hewlett Packard, but I essentially got into this as a business from Hewlett Packard starting about 1982. And so what to many of you will be a new topic or a new subject, the whole focus on the smart factory and automation methodologies, to me, it's been a long subject, and one that hopefully we're going to capture in these 8 lectures. And we're hopefully planning for additional lectures to supplement this eventually. With that, I also bring the experience of serving nearly 15 years in Asia for Hewlett Packard and others, in Taiwan, Hong Kong, and Shenzhen, being the chief technical officer for the world's biggest printed circuit fabrication, in which we talk about multiple factories of 1 million square feet or 100,000 square meter factories. Some of my sites had as many as 35 of these 100,000 square meter automated factories. And, Hunhai, what you call Foxconn, had nearly 7 sites in Asia. So being Hewlett Packard being not necessarily one of the largest fabricators, but as a captive, it was certainly the most diversified, with 7 fabrication facilities around the world that I worked with. And then Foxconn, which is clearly the world's largest, And even though I helped do an IPO that broke Foxconn PCFab up into two organizations called Zending Technology. Zending is now the largest printed circuit fabricator in the world, but people don't realize that that's only half of Foxconn. And so the invisible number one also is still Foxconn because they're still captive and not part of a merchant market. With that, this is the introduction, and getting started is typically the hardest problem and the hardest step. Many times, like I said, you're used to hearing technical talks and other papers at conferences about hardware and software and technology, etc. But getting started yourself is typically the hardest. So we'll go over kind of my approach to who should do it, what you should focus on, how you might do it, how long it might take, when, and how much potentially will it cost. I don't want to come down hard on factory automation consultants, but there are very few of them that are independent consultants in general. I know of only one. The vast majority of the experts have been hired by companies to take their expertise and help them sell their particular hardware or software or process, which is typically how it goes in our industry. Unfortunately, that also restricts many times the solution that they may see or propose, in that it typically will have to probably include their hardware, software, process. I found that from the long run, and doing this for so many years, it's usually a better investment to select your own engineers that are familiar with your process and procedures and teach them how to do the automation planning and the methodology. Then they can teach others, as this is an essential skill, I think, for a process engineer or in our industry. And the factory will need this skill over and over again. The minimum is a team of two engineers, one being a process engineer, usually a chemical engineer, and the other being a control or data engineer, which is usually an electrical engineer. But I also want to say that many times you're going to need access to a statistician, either at a university or a consultant, who are very useful, because we're going to talk later about the use of modeling and digital twin as a methodology to predict and improve yield or quality techniques. And this involves the use of advanced statistical techniques. Both these should be capable of working independently and quickly learning new skills, especially the use of the statistical tools and data analysis we're going to talk about. So new college graduates, especially with a graduate degree, would be suitable if you don't have the particular people currently on your staff, or can get over them. Just be mindful that suitable bonuses and compensations need to be established, as successful factory automation engineers are highly prized and heavily recruited. And would hate to you go through and get all of these people developed and everything, and then lose them out, to be absconded away. But since you're all in this, you realize that that this is not necessarily a skill that a lot of people have in our industry. In terms of what, the most important thing is working with the company's business objective. In other words, the company should already have some long-term business objectives that will shape their priorities for any kind of automation strategy or product roadmap. And this includes, whether or not they're focusing on new customer development, they're focusing on technology expansion, or technology acquisition, new product development, quality focus, reliability focus, or new material. But there should be some higher level company business objective that drives the entire automation strategy and what people will be working on through either a roadmap or some strategic thing. Now, the most obvious area is that one of zero waste. And the waste of any sort, be it rework or repair, paperwork, environmental or manpower waste, are all suitable focuses for benchmarking or looking at best practice analysis to improve performance. As we will talk about the skills, benchmarking or where you are now and looking at best practices, will help you determine where you want to go. And we'll get in later the methodology of what that involves in terms of both mechanization within printed circuit manning or assembly, or software systemization. The Internet of Things sensors, new sensors provide the real-time data that are the basis of most of the smart factory automation. So as we talk about the smart factory, it'll be more than just automation. The smart factory looks to expand through the use of sensors and data and analysis and modeling the ability to, using relevant information, provide predictions of what could happen in order to improve quality or improve delivery or improve the sensitivity or the specification given. We'll talk a little later in the lecture about the specific gravity unit and amp hour units in chapter 4 as maybe a sensor that you can play with. Predictive analytics is also a term that we'll be using over and over again. Using these new sensors, when data stored on the cloud with regression analysis and design of experiment procedures to predict and make predictive models, which are now called digital twins, to reduce or eliminate defects or enhance product specifications like impedance control or registration. Zero defect manufacturing, always a useful one. Unless your yields are 100%, defects typically are your largest waste, and benchmarking will provide project focus there. Driving zero downtime, downtime for equipment and processes that affect the bottom line, and delivery performance with new sensor data and predictive models can eliminate this. And finally, the creation of solution templates, documenting automation solutions with a template that others can follow to solve similar problems and eliminate waste. So how we do that is starting with what you're starting with right now, education. Starting with this paper and learning from these iConnect 007 ebooks. Hopefully you've downloaded already 24 essential skills. We're working with about 17 chapters out of the 24. There's a book, Automation and Advanced Fab Processes. There are 4 chapters there to study, and the automation methodology to learn, future lectures. An important one is this one, Engineering Statistics Handbook. This is a free handbook and software from the US government, from NIST. And it is in our next lecture in studying design of experiments and problem solving. I want to encourage you to download the handbook and the software as soon as possible. You cannot get to this handbook and the software by going to nist.org. It no longer is part of any of the menus, but using the URL provided it's still there, but I can't guarantee how long it will be available. Like I said, it's one of the world's best statistics book. It's a statistics book not written for universities, but written for working process engineers. And that's us folks. And so it's really, really well written by the world's experts. And it provides software that will run on 7 different operating systems. So regardless of the kinds of computers you have, I encourage you to do this. A fourth one is by Siemens, Advanced Manufacturing in the Digital Age, which is a free ebook that we'll use in other lectures from '07. Fifth is data acquisition systems. So we need to study data acquisition systems, sensors, and SCADAs as when we get around to that from like the Instrument Society of America, as well as programmable logic controllers, learning ladder logic and load code programming to utilize low-cost programmable logic controllers with sensors for solutions, and then lastly, creating the solutions template for publication. So 17 chapters are part of this 24 essential skills, kind of checked off here. The double checked are the ones that are really important. They are all useful throughout your career, but not necessarily that useful in the automation methodology, but maybe for other parts of your. But going through at least these 17 is essential for this course. The automation and advanced procedures in PCB, there are 4 chapters to use and study. And in midway, we'll get into the mechanization and automation process, which you've seen here in terms of mechanization classes A through F and systemization levels 1 through 6 in terms of the automation planning methodology. And again, this is the Engineering Statistics Handbook from NIST and Semitech, written for working process engineers. And, you know, this is one of the best. I've had a number of statistics courses in college, but this is not a university approach to statistics. This is the working engineers focus on statistics. And so I'll show you right there, you know, selecting the right statistical tool, very useful chat, but also it includes data plot, which is software that runs on Unix, Windows, Apple XP, Mac, and Linux. Additionally, there's this Advanced Manufacturing in the Digital Age, 2nd edition from Oren Manor that I ask you to download, and we will reference at different times. And finally, download your favorite PLC. If you don't happen to have a PLC, you can go to Siemens, or a very good one that I use is automationdirect.com. You see right here, that will teach you all about programmable logic controllers, sensors, setting up. Otherwise, you can go to National Instruments or ISA, the Instrument Society of America.org, in terms of their websites for their tutorials and information. You know, finally, you may have to supplement the training of throughout this course with some expenses and things like this training course right here for the Raspberry Pi. That's $365 on Amazon and everything US. But excellent coursework of using essentially a smart controller that we'll talk about in future lectures in terms of hands-on that they may not have had chance to do in the university training or anything before. And lastly, anything about sensors. Here, Keysight's Fundamentals of Sensor Measurement is an ebook. The book in the center, Instrument Methods of Chemical Analysis, is the university textbook that I had. I took a graduate course in analytical methods for chemical processes, a chemistry course, but taught by a chemical engineering professor, in which we built 40 or 50 different automatic chemical analytic equipment through a uniquely modular system that I've never seen and been able to run down. You know, very insightful in terms of teaching me the methods of how you put together your own chemical analytic. And then finally, the read for it from Chemical Engineering Magazine on statistics for chemical engineer that's always useful as a reference for people. So how long? Well, once you pick the people, they've got a couple of months of study and preparation just to go through, this course. But also this course, what I'm talking about in these things, I'm spending 15 to 20 minutes about a topic that I learned at a formalized course that may have been from 1 to 5 days. And so my books and the ebooks only introduces how important this is. It does not teach the definitive everything about that topic. You're going to have to do on your own preparation of learning these things in more detail. For that, one of the last lectures will be on distance learning. And so distance learning is the way you're going to improve and learn these in great detail. And I've given you a lot of insight where to look to find the courses that you may want. But you got to remember that, like I said, we're spending 20 minutes on a subject that may be 40 hours or 80 hours or more in the actual to learn that methodology. So once the engineers have been selected and they're preparing, in addition to the iConnect books, as I mentioned, distance learning can provide lean manufacturing, regression analysis, sensors, PLC, and low code training that may be required to implement some of the solutions. But more than anything else is establishing the process for ongoing continuous improvements utilizing a solutions template so that everybody can benefit from this. Now, if your focus happens to be on new product development and not on automation and manpower or replacement of essential workers that difficult to recruit or something like that, you'll go back to the 24 skills and you'll see the thing talked about the new product developments follow the S-shaped curve. So if you're focusing on a totally new technology, that's a slightly different methodology, one that we're not really covering here in this course. This is on automation methodologies. And then understanding the roles of management software is important for predictive analytics and performance visibility. And these are the people that, if you need their products, are very, very useful, that will provide you with the software to help you execute the goals that you set aside for yourself. How much is this? Well, projects can be a few $100s to a few thousand. A few $100s might be when we get to the sensor section, the specific gravity sensor that I developed that I will show you about. I found if you're in printed circuit fabrication with aqueous processes, specific gravity is one of the most important sensors, and yet industrial specific gravity sensors are very, very expensive. So I'll show you how to build your own low-cost one that's more sensitive than anything you can possibly buy, working with your maintenance department or an outside fabricator. And if it's something larger, we also have available the robot panel carrier in case you would want to automate the handling of panels through a new process or a very sensitive process. You could utilize a local fabricator to build the Panet robot processor carrier from our blueprints. That can cost only $5,000 US. That's in chapter 3. But whatever you're doing, it depends on the roadmap that you're establishing. I can't guess what your priority is going to be, whether or not labor sensitivity, expansion of product line, expansion of capacity, reduction of losses, and improvement in productivity. Your business goals can be anything and everything, but whatever it is, uh, you know, this will help you establish those roadmaps and the product life cycles, and to employ the new solution templates that we developed. The Factory 4.0 they talk about, the smart factory, really comes from three focuses. The first part, sensing, integrating real-time tools, processes, and WIP monitoring, connecting those sensors using difficult and unique data sources into digitization and information, and then using that to predict and develop digital twins to enable predictive applications that provide an advantage that simple automation doesn't always provide. And that's why this has two titles, automation and the smart factory. The smart factory is one of those goals that can have tremendous paybacks, but there's a lot of kind of homework and steps that lead up to being able to implement a smart factory. Again, these three focuses are predominantly what the 8 lectures are about. But it all starts with sensors. My favorite are the electrochemical sensors. You've seen here, capacitance, conductivity, pH or ion selective, oxidation reduction, or cyclic photometric stripping. In terms of specificity, sensitivity, conducting fluids or not, non-conducting fluid, maintenance, installation, and cost. And that's why, like I said, a few minutes on this doesn't tell you much. You need to spend a little more time on one of the sensor tutorials to find out more about each of these sensors. But believe me, I've used all of them in printed circuit assembly and printed circuit fabrication, as well as semiconductor and thin film fabrication. The specific gravity sensors, the one that you're familiar with is probably the hydrometer, number one up there, because that's a simple weighted glass device you can buy and drop into the solution and read its specific gravity. There are displacers, hydrostatic head, radiation, weight of a fixed volume, and vibrating U-tubes. In terms of it, we're focused mainly on device methods 2 and 3. My other favorite one is spectrophotometers, and that's because we work with copper and gold and nickel and other metals, palladium. All of these metals are very distinguished absorbents in aqueous and other solutions. Consequently, spectrophotometer is an incredibly useful machine, also in environmental energy. And as I've shown here, they were very, very expensive devices, but today you can go to my reference on this famous LEGO spectrophotometer being used by junior high and high school students all around the world to do research and publish papers. If you want to be impressed, read some of the papers published by these high school students using this LEGO spectrophotometer. We're not talking about thousands of dollars here. We're talking about a few dollars. In fact, there on the left-hand side, you can make a spectrophotometer out of your smartphone, a grating, and a battery and a light-emitting diode. But those sensors have to feed into these various data acquisition systems here. This one I'm showing you on the top, a 4-channel one, starts at $85. So we're not talking about enormously expensive ones. This 8-channel analog one with Ethernet is $800. You can deal with much more complex Ethernet ones down below, go up to 1,000 volts at $3,400, or even the Keysight 6-digit 20-channel one for 3,400 US dollars. What drives all those are these various new microcomputers. I find these very cost effective. The Arduino, $40. The Raspberry Pi 4, my favorite, is $42. And there on the right-hand side are data acquisition hats that plug into the Raspberry Pi directly that start at $99 in terms of a sensor. So once you've worked out with your sensors and what new sensors to use, these systems provide the ability to have networking, monitoring, display, everything for as little as $42. So great learning tool, and the elements of automation. More complex is the typical management architecture for a factory and control system for analysis and execution. This requires a little more reading and work, but you can see here in terms of advanced software focused on recipe management, statistical process control, advanced process control, fault detection, location tracking, material handling, equipment, computer interfaces, the manufacturing execution systems connecting all of this, and then engineering and yield management systems, equipment state tracking, operator interfaces, production reporting, cycle time and output, and cube time breakdown, digital twin, smart learning, and enhanced tools prevent breakdown and preventing maintenance scheduling. So this is the advanced side of the software that goes into this for people. So industrial Internet of Things and predictive analysis is driving a zero downtime, zero defect manufacturing focus. First of all, setting the stage in the business case for predictive analytics. And predictive analytics, makes the focus of zero downtime, zero defect manufacturing much visible in terms of real-time data collection and visibility, in terms of overall improvement of equipment effectiveness and performance and quality. 5 to 10% gains in equipment effectiveness, or 10 to 25% gains in labor productivity. In terms of reducing unplanned downtime or optimizing spare parts, or improving predictive maintenance scheduling, a 1 to 5% improvement in utilization gains, or 10 to 20% reduction in spare parts, or eliminating overhead maintenance. And then predictive quality, reducing waste in terms of scrap reduction, or reducing the cost, the quality issues, and inspecting, savings per plant annually. These are very real gains that provide some of the focus of what the roadmap should be. And so, traditional methods that were developed in the past in terms of reactive maintenance or product testing or manual inspection, statistical process control or process monitoring, the smart manufacturing, is looking to make that predictive maintenance, the benefit to reduce unplanned downtime, to improve uptime, optimize maintenance planning, increase productivity. Instead of product testing and manual inspection, predictive quality to improve product quality, reduce scrap, reduce inspection and testing costs, and reduce wasted production time. And in the statistical process control, moving on now to predictive process monitoring to improve product quality, reduce scrap, and detect process drifts before bad parts are produced. Again, through the use of the sensors, the data modeling, the digital twin, and then the methodologies to project to the future to eliminate problems before they start. So predictive analysis is kind of the transformational part of the Industry 4.0 technology, moving from something like in maintenance, reactive maintenance, we fix what has failed in firefight, to preventive maintenance, reliability centered maintenance, to condition based maintenance, where the needs and condition monitoring, to prognostic and health management in terms of predictive maintenance and optimal thing in which we understand the health of a process, machine, or technique. And then as we see it starting to deviate, we can then prepare for fixing that offline before it breaks and shuts a lot of essential people and productivity down. That's the goal of this Industry 4.0 is this predictive analytics. But we've got to have a number of steps in place before we can get to that thing. When you hear about artificial intelligence, machine learning, and deep learning, well, artificial intelligence is the science of getting computers to act intelligently without being explicitly programmed. Machine learning is a sub-discipline of AI focused on using math-based algorithms and software to mimic smart actions. And deep learning is a statistical machine learning approach based on deep neural networks. Right now, a lot of that is not in our industry, but as we start to employ more robots, some of these are beginning to show up. In the past, what I was working with is rule-based automation, RPA or RBA, that, especially in robotic process automation. But machine learning, supervised learning, and artificial intelligence is providing vast gains in the ability to working with these tools that we haven't had in the past. But it depends on a number of things that right now we don't use a lot of sophisticated robots like automotive and other industries do. But, we are sensitive to unplanned downtime, and that can cost thousands of dollars. So predictive analytics, taking the guesswork out of production and maintenance planning, replacing it with accurate predictions that allow for worry-free manufacturing, is something that's important to all of us in terms of the manufacturing process we deal with. So a systematic approach to predictive analysis needs to be taken. So provided here is 6 kind of simple illustrations of the predictive analytics. So the technology and solution templates, the automation matrix, and gap analysis is part of that. So you can see here process control, industrial robots, machine tools, advanced processes, test, AOI, equipment utility in terms of creating a solution template. For industrial maintenance, the moving from preventive maintenance to predictive maintenance is important in that, especially if you're using a robot manufacturing. Non-intrusive data models from PLCs can include here. Intuitive maintenance health dashboards, data-driven robotic health analytics, and AI predictive algorithms to generate are involved. With this, you can see the health assessment data collected on a robot, and then the prediction in terms of when it might fail, so that can be prevented. Injection molding machine, predictive maintenance and quality for injection molding machines, like from collecting the data from sensors, data cleaning, and then data segmentation, or to the health index and analysts. Or a PDX for an SMT line to demonstrate a predictive performance capability of SMT equipment. SMT equipment includes, printers, pick and place, AOI, reflow, and the following critical components. Existing data collected from systems using appropriate protocols like the IPC CFX, and then turned into a solution template for pattern recognition and correlation models. An SMC data set overview might be, number of input factors, 10 category variables, number of output measures, 3 positional accuracies, X, Y, and Z, and rotational angle, time duration data set, number of data rows, number of machine units, number of feeders in machines. For a single machine, there are over 3 million records in a 1 month of data with regards to 96 different nozzles and 17 different feeders. And so for the actual data map, in terms of the solution template, would be date and time, part number, vendor name, lot number, serial number of the work, machine ID, slot ID, feeder ID, header, nozzle, error code if nozzle fails to pick up, positional accuracy in X, Y, and Z, actual versus command, error code related to nozzle, vacuum pressure, and other data optional. For a data map for a PCB, say for etching, a solution template, similar in terms of etcher, conveyor speed, centimeters per minute, pump pressure, pump 1, pump 2 temperature, the etchant specific gravity or Baume, pH, ORP, and other data like colorimetric data. So, these types of data collection all put together in order to find a solution. How does this all fit, in the race of automation? Well, that's interesting. This is my personal prediction of a map. When we go from design to DFM and handoff to printed circuit board fabrication to assembly, process engineering, the assembly and test, and the box build, the automation is not necessarily going to be one solution fits all. And so in terms of design, the IPC 2581 is clearly one of the ones. But after the handoff, if the handoff from design is to PC fabrication, then we're likely to see the GEM standard from SEMI utilizing. Is the handoff is to elect a process assembly and assembly process engineering, then the IPC CFX, and to assembly and tests, again, IPC CFX. But if the handoff from assembly and process engineering is to robotic box build, then we may see OML and the MAP standard for the box build rather than the board stuffing. So if there's going to be a race to the finish, it may be a multi-horse tie when it comes to finish there. No way to predict which way. The last part is, a systematic approach to winning with a return on investment analytics. So predictive analytics and the journey there help you find the proof of value. And that is, the assembling the team, benchmarking the plant, discovering, doing the technical workshops and experimentation and gap analysis for people, processes, and technologies to identify what is to be focused on, what is the improvement, which will achieve an ROI in the design. And then, stating the work, developing the hardware, software, and services to assemble the required components for the infrastructure, and then delivering on that plan and achieving the return on investment as the proof of value and scaling that. This is the whole point, is to think big, start small, prove the value, and scale fast. So key takeaways from this is that, start your smart factory journey today. Think big, but start small and act now. Don't tackle something that's too difficult, but look to staff the automation team with your own engineers, plus the appropriate training and timing to learn those skills. Initiate a smart factory assessment, then make it operational with the proof of value in terms of ROI. This is a fundamental business transition, aligning the technology of the business objectives. I can't predict what your business objectives are, but whatever they are, the next 5 years is a terrific opportunity. We're going to see a lot of investment in the next 5 years, a lot of growth in the semiconductor fabrication of chips in the next 5 years, a lot of need for printed circuit boards, and a lot of very complex printed circuit boards coming down the line because of 5G and 6G, 7G, autonomous vehicles, and other smart devices that are beginning to take over everything. So I see a terrifically opportunity for growth in printed circuits and assembly. How to take advantage of that and the connectivity and the opportunity for investment to improve whatever it is that makes up your company's performance description in terms of improving that, to improve your weakest link, be it people, processes, or technology, because the benefits will only accrue as far as the weakest link will permit. With that, I want to thank you for your time. And like I said, have you any questions, send them to me. And like I say, it helps you to do the reading that you've been sent about the different lectures ahead of time. That way you have to focus less on the notes and more on the actual slides and what I may say about them. With that, ICT and myself, thank you for your time. And now back to William.
Yeah, thanks, Happy. If we can wrap up at this point, that would keep us on track. And as Happy said, any questions, send them direct to Happy and we can get you an answer. I'll be sending out a link for session 2 later this week, and we will also get all the sessions on our website for catch up, but not tonight. Okay, thank you. And thank you for attending, and goodbye.
Cheerio.
Bye.
Bye. Thank you.
That went okay, Pete.
I thought that was brilliant.
It was, yeah. There was,
No,
it was over 30 in, so I'm quite impressed.
Yeah. Well, I noticed that there were sort of 24 nominal participants, but places like Graphic, where you've got a group of people.
That's right. They've got a conference room, and the same with Linkolek. So they've got they have 5 or 6 in there. So yeah.
And I think they are companies that will take it very, very seriously.
Yes.
And will effectively put a group together